In section 3.6 they talk about graphing rational functions, and a rational function is just one polynomial over another polynomial. You can have one polynomial p and another polynomial r, and it's just analyzing the graph to see what it looks like. Well, it's going to have these things called asymptotes. An asymptote is a place where the graph is attracted towards it but doesn't touch it. And on a rare occasion it will actually cross it, but it's only on the horizontal asymptotes. The vertical asymptotes, it'll get closer and closer, but it'll never touch. It'll get real close and never touch. Same thing with the slant. It'll get really close, but it won't touch. So how do you find these three different asymptotes? The vertical asymptote, or VA, is found by setting the denominator equal to 0 and solving. X equals each of these zeros are the vertical asymptotes. They're vertical lines that x equals a number, and there can be multiple of them. Horizontal asymptotes is a little more complicated. Horizontal, you have to set the numerator's degree and call it n, and the denominator's degree and call it m, and then compare them. If n is smaller than m, then it has a horizontal asymptote at y equals 0, the x-axis. If n equals m, then the horizontal asymptote is y equals the leading coefficients of the top and the bottom. You ignore the x's, just the leading coefficient. If n is greater than m, then there's no horizontal asymptote. Okay? So, also, if n is just 1 degree larger than m, then you use long division. You do long division, and your slant asymptote is just y equals your quotient, ignoring your remainder, just the quotient. So what are the steps for graphing a rational function? You factor everything. Factor the numerator, factor the denominator. You find your x-intercepts by setting the numerator equal to 0 and solving. Find the y-intercepts by letting x equal 0. Okay, so then you find your vertical asymptotes, your horizontal asymptotes, and a slant if it has one. And then you finally sketch your graph. So let's do a few problems. There's not many in this section. First one is this one. Okay, if you factor the top, you get this guy here. Setting each one equal to 0, you get these two numbers. Those are your x-intercepts. Okay. The y-intercept, you let x equal 0, and you get 1 over 0, so there's no y-intercept. Okay, if you factor the top, you get this guy. You factor the bottom, you get this guy. Okay, so your vertical asymptote is just x equals each of those zeros, and we found the zeros to be x equals 0 and x equals 3 for the denominator. Your horizontal, you have to look at the degree of the top, which is 2 when you square it, and squared and first power gives you 3 on the bottom. So n is 1 degree smaller than m, so you know that it has an asymptote at the y equals 0. And you don't have to worry about any of the rest of those. Okay, so at y equals 0, at x equals 0, and at x equals 3. And notice it approaches each one of these asymptotes. It gets closer and closer to each one, but it never touches. Now your domain, keep in mind this one number at 0 and at 3 is not included in your domain. It's every other number. Every number all the way up to, but not including 3, or not including 0, and not including 3. So, minus infinity to 0, union 0 to 3, union 3 to infinity. Now your range, it's everything to infinity and to minus infinity except at 0. So minus infinity to 0, union 0 to infinity. Okay, now 64. When you factor that one, it looks like this, and this one factors this way. Okay, now they want you to find your x-intercept, so you set everything equal to 0. Okay, and I found the 3 x-intercepts for this guy, but you can also, well, I didn't know how that factored until after I did this work. And I get 2, -1, and -1. Now my x-intercepts are where my numerator equals 0, so I get 0 and 1. My y-intercept is split x equals 0, and you get 0 over -2, which is just 0. Vertical asymptote is where you get your denominator equals 0, and you get 2 and negative 1. Okay? And your horizontal asymptote is at y equals the leading coefficient over leading coefficient. So it's 1 over 1. Y equals 1 over 1, or just y equals 1. So there it is at 1. There's your other asymptotes. And notice this guy actually does cross. It's very rare, but it does actually cross. And there's your other two asymptotes. If you check points greater than 2 and less than negative 1, you'll see that it's above here and it's above there. And you check a few points in here and you'll see what it's doing. Okay? It's not always easy to see, but you got to check a lot of points very close to each other. Now 75, degree 2 over degree 1. So the top is bigger than the bottom, so you're not going to have a horizontal. Okay? But you will have a slant. Now how do you do the slant? You do long division with this guy, and you ignore your remainder. You just use the quotient. Y equals your quotient. And so y equals x plus 8 is your slant. X equals 3 is your vertical. And if you graph some points, you'll see that it does this. Very unusual graph. And 77 also has a slant, because the top is 1 degree bigger than the bottom. So you do long division with the bottom into the top, and you get all this. Ignore your remainder. Y equals this is your slant. There it is. Y equals x plus 1. And your vertical is at x equals 2 and x equals minus 2. Those are the places where your denominator equals 0. So again, you've got two verticals at minus 2 and 2. You got your slant at x plus 1. Y equals x plus 1. And when you graph some other points here, you see that it's got all these curves here. You got to graph quite a few points, like at 3, 4, and 5 to see that it's up here, and at minus 3, 4, 5, and so on to see that it's down here.